Hold on a second. I need a cool way to introduce this. In a galaxy not at all far away, on the south coast of England, lies 4 coastal kingdoms in the midst of war with the ocean. Faced with uncontrollable storms, daunting waves and large-scale erosions, we, the coastal engineers, must do whatever it takes to stop these attacks and protect our beloved coasts. Now, on a more serious note, I'll begin talking about the coastal defense strategies implemented in the BRIGHTON Marina. The case of the sea cliff erosion within Black Rock in Brighton has long been a serious issue. In this photo taken in 1911, the construction of a massive groin can be seen in an attempt to absorb strong wave action. However, this was proven to be insufficient as cracks were visible at the top of the cliff, implying that a cliff fall was still imminent. In the 1930s, the Brighton Corporation tried to solve this issue by constructing a concrete seawall at the base of the cliff. This was, however, again not enough. As a result of this, plans to build a marina and harbour were therefore implemented and approved. In 1971, construction of the Brighton Marina finally began. It comprised of 2 large breakwaters, the east and the west breakwaters, which were made up of a massive 110 caissons. Erecting these caissons, however, were proven difficult over the years, as unusual bad weather, such as heavy storms, damaged several of the newly built caissons, causing much delay in the construction process. However, despite the delay and costing £41 million, a value far more than initially expected, the marina officially opened for use in 1978. It successfully functions as expected, where it effectively acts as a breakwater, absorbing strong wave actions during all times of the existing high tidal range. Further protecting this breakwater are these man-made concrete rocks comprising of complex geometrical shapes designed to interlock with each other. This allows for further effective defense against the erosive force of ocean waves. In addition, they are cheap to cast and avoids high expenditure on the importing of Scandinavian rocks. And now, as a result, the Brighton Marina consists of a working harbour, residential housing, and a range of leisure and commercial activities for existing locals and tourists to enjoy. Moving further east of the coastline, we find the BIRLING GAP. Again, a similar case to that of the Black Rock sea cliffs, whereby severe wave forces causes large-scale erosions. Over the years, it is evident that a large portion of sea cliff has again been heavily eroded due to strong forces of the ocean waves. Further exacerbating the situation is the apparent top-down erosion due to rain effects. Existing fracture lines within the chalk profile of the sea cliff allows frost to develop and cause this top-down erosion. So, what has been done to stop this massive attack on this picturesque terrain, you may ask? The simple answer is nothing. Yes, nothing. The current strategy to simply let natural erosion occur has been due to the Natural Trust attempting to conserve a unique heritage site and is a great example of a marine nature reserve. Able to erode up to a meter annually, the sea cliffs, consisting majority of chalk, washes away into the ocean while the hard and crystalline nature of existing flint remains on the shoreline, making up the shingle beach. This, however, instigates social issues, as many property owners edging the sea cliffs are keen to maintain their land. They want to protect and defend the BIRLING GAP from further erosion. The question for the coastal engineer is what to do. Continue doing nothing? Or implement coastal defense? Maybe find a balance between the two? Now that's the million-dollar question. No one really knows. But on that note of coastal defense, thinking about possible solutions, if the BIRLING GAP were to be protected, offshore breakwaters would probably be a feasible answer. Due to the high tidal range, low neap tides would require these breakwaters to be underwater. This in effect would be less of an environmental and visual harm towards the site. However, then again, any coastal defense systems here may prove to be inadequate to stop the erosion and may simply slow down the process. Moving even further east of the coastline, we can find the EASTBOURNE Promenade, another tourist attraction threatened by ocean forces. Consisting of main roads, commercial and residential buildings directly adjacent to the beach, coastal defense is essential. The beach consists of 3 lines of defense, stretching from the base of the beach all the way up to the main road. First in line is the shingle recharge at the bottom of the beach, followed by approximately 10 meters of horizontal reserve for cases of high tides and storms. Now, if these fail, backing up the beach shingle is the construction of a seawall consisting of a wave returning wall and a brick wall with sealable gates. Now from this, it is evident that the Eastbourne Promenade is heavily prepared for any heavy wave action. Despite the stability of shingle as a primary form of coastal defense, the vast amounts of shingle induces issues such as longshore drifts and forces. When first looked at, the immediate reaction to the Eastbourne Promenade would be towards the field of closely spaced timber groins, and are the main way of retaining and controlling this longshore drift of the beach shingle. It is therefore evident that within the groins that large tree trunks are used to anchor these timber groins in order to provide additional support for the structure and to resist the large overturning moments. These groins have been in place for approximately 5 to 10 years and are expected to last for another 10 to 15. Further east of Eastbourne, another issue arises in Pevensey Bay Beach. It can be observed that the beach profile and wave action is similar to the Eastbourne Promenade. However, yet again, a different strategy is implemented here. Now, the key physical features of the beach are essentially 2 million cubic meters of shingle distributed over 9 kilometers. It is able to move around under wave action to the extent that its shape can alter rapidly, sometimes within a few hours. Here, the Pevensey Bay Beach is known to be the very first sea defense project in the world to be funded as a public-private partnership, or also known as PPP. The strategy consists of constant supervision, as it is now the most monitored beach in the UK. The main strategy here is to monitor, manage, and maintain shingle supply as it drives from the west to the east, due to prevailing wave action and longshore drift. Now, how is it maintained, and what works are being done on the beach? Well, bulldozers are used throughout the winter for reprofiling of the upper foreshore and to move sediments back up the beach due to storms drawing them down. Furthermore, these excessive beach movements require large dump trucks loaded from areas of temporary accretion and then are deposited in areas of depletion caused by erosion. Mechanical bypassing is also required in the west area of the beach, where the Sovereign Harbour Marina exists. This is because shingle washed onto its western harbour arm is now required to be mechanically bypassed around to the other side of the harbour, into the downdrift side. Taking into account all this shingle movement and reprofiling, it is noted that annual replenishment of sea dredge aggregate is necessary to sustain this defense strategy. One of the main reasons as why this strategy is implemented in the first place is due to the simple fact that it is easier and more cost-effective to move the shingle along the foreshore rather than building or maintaining any type of coastal defense structure in the first place. And on that note, I'd just like to say thank you for listening. And remember, may the force be with you.